Today, I spent the morning rethinking my approach to this course. You see, the owners of a certain soundtrack score that I used for an exhilarating 12 seconds in the last lesson decided that they were going to pocket the 55-gallon drums full of money we earn from the ad revenue this video is bringing in. Dude, relax. I crunched the numbers, and I'm 72% confident that 100% of $0 is $0. Or was that the other way around? Well, enough of that. We now know how to configure, load content, control playback, and synchronize our RidePlayer with other systems. There's just one major piece of the puzzle remaining: linking these capabilities to the ride control system. Since the ride vehicles, or rather the humans inside them, are the main focus of the attraction, it makes sense for ride systems to trigger the show experience. Let's talk about how this works. Most ride control systems are based upon a device called a programmable logic controller, or PLC for short. This is a very special type of control system that's geared towards industrial automation and safety. Whether it's a factory or a theme park ride, PLCs are responsible for moving around heavy equipment that could very easily cause harm. Since killing or maiming guests is frowned upon, both the hardware and software of these systems are designed with foolproof operation in mind. You know, like making sure Bob will still be your uncle, even if he's dumb enough to stand on the giant flamethrower nozzle during the grand finale. While PLCs are great for industrial automation and safety, they're not at all designed for show control. That's where devices like the V16X and RidePlayer come in. It's simple, really. The PLCs run the ride equipment. The show controllers run the show equipment. And the two systems coordinate with each other over a network link. The trick is standardizing on the information we share over that network link. Before we get to that, let's look a little deeper into how ride systems are structured. Rides typically have a pretty linear experience. In this example, I'm showing a ride that's 5 minutes long. The ride system usually views this timeline in milliseconds, like so. Most rides are also divided into scenes, with each scene having a multi-system experience designed to coordinate with onboard audio. This would include things like video projections, special effects, or animated figures within view of the ride vehicle. When you add ride vehicles into the mix, they travel down the ride path from scene to scene, always precisely aware of their position within the experience. Not because the ride system cares about show experience, but because being aware of ride vehicle positions is pretty helpful when it comes to not crashing multi-million-dollar vehicles into one another like fairground bumper cars. This precision comes in handy for show control systems like RidePlayer because it can translate it into show timecode and calculate exactly where it should be in the show experience. So to circle back on that whole shared information thing that I obnoxiously punted on earlier, the type of data we need to retrieve from the PLC are things like vehicle position. With this, RidePlayer can trigger the show systems at the right moments. We also need to know a few other basic things, like whether or not the ride vehicle is running. This allows RidePlayer to gracefully handle the guest experience when the vehicle stops or resumes. I know you hate when I do this, but I promise we'll talk more about that in a little bit. For now, let's learn how to configure RidePlayer to get this information from the PLC. Alright, I'm going to start off by opening up the project that we left off with earlier. Now it's a little different. I took the liberty of extracting this out to 6 scenes, like in my example that I just showed you. I still have my timelines, like we already did earlier. And I've also extracted out 6 scene starts. We only did 1 earlier, but basically each one of these simply starts the onboard and the offboard timeline for each scene. I also went ahead and removed that input trigger for scene 1. We were just doing that earlier as an example because that was a total kludge. We wouldn't do it that way in the real world. Alright, so the next step is to add the PLC to our device list. I'm just going to go here and click New. I'm going to call it the VCS for Vehicle Control System. The most common system we integrate with is called the Allen Bradley Control Logics or Guard Logics platform. So just like so. And I just need to specify where that PLC is IP-wise. just like so. Okay, so far so good. All right, so that will allow the RidePlayer to talk to the PLC. The next step is setting up the relationship that allows us to get the data that we need. And that is done up here. We're going to go ahead and drop this drop-down box and select the PLC, VCS. And then I'm going to go ahead and double-click on Device Variables over here. All right, so this pulls up the list of device variables for the PLC. These ones we see here, we don't have the ability to control whether they're here or not. They are automatically created by adding the device to our project. However, I'm going to go ahead and click New right here to create a new special variable that stores data from the PLC. This will become clearer in a moment, but I'm going to choose to name this variable VCS to RP for RidePlayer. And the reason why is this single variable is going to retrieve all the information I need. That includes the vehicle position and the vehicle status. If we look at the top here, it says synchronize variable with PLC tag. Variables are how we refer to stored information on our side, the RidePlayer side. Tags are how they refer to stored information on the PLC side. All we're really doing here is setting up a relationship between variables on our side with tags on the PLC side so that information is synchronized regularly. So, this is going to be a read operation. The RidePlayer is reading data from the PLC. This right here specifies how often to read that data. I'm going to read it every frame, so very often. And right here, we have to enter the name of the PLC tag on the other side. This has to be exact, case sensitive and everything. So it is called VCS _2 _RP for RidePlayer. Down here, we select the data type on the PLC side. There's different types of integers, int, double int, signed int, etc. So make sure that this matches exactly. No matter what kind it is on the PLC side, it will get converted into an integer on our side. Okay, so this is an integer data type on our side. Another super important thing here is we're actually going to retrieve an array. It's very common for PLCs to store information in tag arrays, and actually retrieving it that way is the most efficient way to do so. So I'm going to go ahead and set this up for two array elements. One will hold the position, the other will hold the vehicle status. Okay, so here's our array right here. Notice that we have two elements. Now it might be kind of hard to remember what these elements mean. So we're going to take advantage of this alias feature right here. Remember I said that the first element is going to be the ride vehicle's position. So I'm going to call it int position. The second element contains the vehicle's status. So I might call it something like int status. Now if I expand this out further, we'll see that int status has lots of bits. These could be used for lots of things. I just need to flag one of them to choose whether the ride vehicle is running or not. So I'm going to call bit 0 be running. What's really cool is once I push this project to the RidePlayer, it'll automatically connect to the PLC and start synchronizing that tag data with our local variables. So we can see them updating right here in the watch list. Very powerful. Now that we know the status and position of the ride vehicle, how do we use it? Let's consider this diagram that shows how the position value progresses from scene to scene. In this example, we can see that the show experience for scene 4 needs to start playing exactly 136 seconds into the ride path. Remember that whole reaction time, schedule things for the future thing we talked about? Yeah, now you're getting it. I'm starting to think your boss should take back all those things they said about you when they signed you up for this course. You are easily on your way to earning at least an F+. As you have no doubt deduced using your superior intellect, and maybe a little help from this diagram, all we have to do here is schedule scene 4 to trigger at an earlier time. For the sake of simplicity, I'm triggering playback exactly 1 second before scene 4 begins. Let's see how we do this within our WinScript project. As you can see here, I still have my 6 sequences that are designed to start the scene timelines. What I've done is added triggers that evaluate the vehicle's position, and when it's within a certain range, it triggers the sequence for the appropriate scene. I've also added a new variable to keep track of what scene we are in. That was done here in the variables list. Here's an example of one of those scene sequences. The first thing I do is evaluate whether or not we are already in this scene. The reason why is that this sequence is going to get triggered multiple times. In fact, it's going to be triggered the entire time the vehicle's within this range. So I simply want to make sure that I've only triggered it once. Okay, after I check that, I set the current scene value to the value of this scene, and then I do that synchronous start that we learned earlier. That's simple. With these triggers in place, the ride vehicle's position will automatically trigger the scene timelines when the vehicle enters the scene. While we've got your brain in a blender, let's toss you another curveball. What if the vehicle stops in the middle of the ride path? This is pretty common, especially for Omnimover style attractions with moving load platforms. If a guest needs a little extra time to board, we don't really have the option of letting them fly off the end of the load platform. Once we get them boarded and confiscate their selfie stick, what happens to the vehicles when the ride starts back up? Well, before the RidePlayer revolution, really the only thing systems could do was wait until the next scene trigger. This translated into awkwardly bouncing guests around in ride vehicle in complete silence until they arrived at the next scene. Thanks to the tight relationship between RidePlayer and the ride control system, RidePlayer knows the exact position of the vehicle at all times. Using the power of show control, it can calculate where the show experience should be as soon as the vehicle's back up and running. No need to wait for the next scene. With the Alcorn McBride ecosystem and the right equipment, we can kick off all the ride scenes right where they left off. Let's look at an example of this in action. First, let's start with the easy part, stopping the show when the ride stops. So we can see here the first thing I did was I created a new sequence called Ride Stop. It is triggered whenever VCS.BRunning goes to a value of 0, indicating that the ride vehicle has stopped. If we look at the contents of this, you can see here that I just do a couple of simple things. First, I issue a stop to the wayside system, the offboard V16X. It can take care of whatever that means on its end. Locally, I stop any timeline that could be running, any of our 6. And last but not least, I clear the last scene number, just indicating that no scene is in progress. That'll come in handy later. Next, I'm going to create 2 new variables. These are going to be timecode variables for the purpose of converting from that millisecond position from the ride vehicle to a hours, minutes, seconds frame position, a timecode position for our show timelines. Okay, these are going to be timecode variables. And for this one, I'm going to make it 1000 frames per second, or a millisecond frame rate. I'm going to create another one here. Now this one's going to be a timecode variable as well. It's going to be operating at my show frame rate, 60 frames per second. Now for the fun part. Re-triggering the right scene at the right offset when the vehicle starts moving again. Now keep in mind that I'm tracking whether or not the vehicle is running and the vehicle's position. The vehicle's position will automatically trigger the right scene trigger, like this one. Now if we look at this, you can see that I've added a lot of extra stuff here. First, I check to see if the ride vehicle is running. If it's not, I don't need to do any of these things. Next, I check to see if this scene is already running. If it is, I also don't need to do any of these things. After that, I update int scene to let it know that I'm now running scene 2. The next thing I need to do is convert the millisecond ride vehicle position to a timecode that is an offset into my scene 2 timeline. So stick with me here. The first thing I need to do is grab the current vehicle's position, remembering that that's in milliseconds. And I'm going to copy it to my milliseconds variable that I created earlier. Now, That milliseconds value is representative of the entire ride path, not the portion that's just scene 2. So what I need to do next is subtract the offset in which scene 2 begins. Scene 2 starts at 55,000 milliseconds. So once I subtract that, I'll have the sequence offset. What I'll then do is convert that milliseconds value into a timecode value that is frame-based. And then below, you'll notice that this is very similar to what I was doing before. I'm still calling those two timeline sequences and telling them to start synchronously, but I've added an additional parameter here, and that is that timecode offset. Rather than these sequences starting from the beginning, they will start from this offset. So all of these calculations jump to the appropriate position within these timelines. I've updated these changes to the RidePlayer, and we can see here that the vehicle is currently stopped, and it's stopped at a position that's somewhere in the middle of scene 2. What I'm going to go ahead and do now is resume the ride vehicle, and we'll see how it will jump to the middle of this timeline. Here we go. Pretty cool, huh? I'm going to go ahead and stop the vehicle now. Okay, we're now stopped in the middle of scene 2 again, and again the vehicle resumes. Simple stuff. Hopefully it's easy to see now that with very little effort, you can use RidePlayer to drastically improve guest experience and attraction throughput. Just imagine all of those smiling faces buying $8 sodas rather than standing in queue lines. Add those revenues to our barrels of YouTube cash and you're all set, my friend. I know what you're going to say, and you're welcome. See you in the next lesson.